Hello everyone, this is the second video in the chapter summaries for A2 statistics. This is chapter 2, which covers conditional probability. So first of all, looking at our objectives, our first one is to understand set notation in probability. Our second one is to understand conditional probability. Our third is to use two-way tables in Venn diagrams of conditional probability. Our fourth is to use probability formulae to solve problems. And finally, use tree diagrams with conditional probability. And then to finish off with an exam question. So there are a few symbols you need to understand and use when it comes to set notation in probability. The first one is this sort of U shape here, which represents union. And for example, if we have A union B, that represents either A or B or both. And we can represent this on a Venn diagram. So this is the whole sample space. We have A here and B here. Then A union B would be this entire section here. The next symbol we need to know and understand is this symbol, which looks sort of like an N. And this represents intersection. So A intersection B represents just A and B. So on the Venn diagram, that would be this area here. And finally, we need to know what the dash means. So this just means not whatever came before it. So for example, A union B dash represents not A or B or both. So that would represent everything outside of the two circles. So neither A or B or both. Moving on to conditional probability. So conditional probability is basically the idea that we can work out a probability of a certain event happening given that another event has happened. So for example, the probability that you're late for work given that, which is represented by this vertical line, given that you overslept. And that would be different to the probability that you're late for work given that you got up on time. And so conditional probability deals with these different situations, and it follows that for independent events, A and B, probability of A given B happening is exactly the same as the probability of A happening, because B has no effect on A, and similarly the probability that B given that A happens is equal to the probability of B. And these two conditions can be used to determine whether two events are independent. Moving on to two-way tables, drawn out an example of a two-way table for you. Let's say we're trying to find the probability that someone has brown eyes given that they have black hair. So to do this, we have to restrict the sample space. So we know that we're looking for the probability that you have brown eyes given that you have black hair. So this is the only column that we're interested in. So we're going to isolate this column here. So now we're looking for how many people have brown eyes out of all of the people who have black hair. So that is 2 people out of the 11. So we can see that this is equal to 2 over 11. We can do a similar sort of thing with Venn diagrams. Let's say we're looking for the probability of not B given C. So first of all, We know that we're given C, so we have to restrict the sample space to just C. So we're ignoring everything outside of C. And now we're asked to find the probability of not B given C. So out of 0.3 and 0.2, 0.2 is outside of B. So we can see that this probability is equal to 0.2 out of the entire circle C. So over 0.3 plus 0.2, which is 0.5, and this is equal to 2/5. Moving on to probability formulae, there are two main ones that you need to know. The first one is the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersection B. So to see why this is the case, we can look at a Venn diagram. So we have event A here and event B here. Then we're trying to find the entire area here, which I'll do in red, inside A and B, or A and B. Now what we've done in the formula is we've added the probability of A and the probability of B together. So that gives us this area here, and this area here. But we can see the intersection of A and B, we've counted this twice. So you also need to take away one lot of the intersection, so that the probability of A plus the probability of B minus the probability of A intersection B gives us the probability of A union B, which is A or B or A and B. So that is our first probability formula. And our second probability formula says that the probability of B given A is equal to the probability of B intersection A over the probability of A. And this is equivalent to restricting the sample size in the two-way tables and the Venn diagrams. So this probability A here is the probability of the entire restricted sample size. And this probability on top, B intersection A, is the section of the restricted sample size where we have B and A happening at the same time. And we can rearrange this formula to get the probability of B intersection A being equal to the probability of B given A times the probability of A, which is called the multiplication formula for conditional probability. And finally, looking at tree diagrams with conditional probability, let's say our first branch is A and not A, and then our next branch is B or not B. Now we can see that this probability here is a probability of A happening, and this here is a probability of A dash happening, and this probability here is B happening given that A has happened following the branch across, and here is the probability that B dash has happened given that A has happened. And on the other side, we have the probability of B happening given that A dash has happened. And here we have the probability of B dash happening given that A dash has happened. And from this, we can see that the multiplication formula for conditional probability applies. Following this top branch gives us that the probability of A times the probability of B given A is equal to the probability of A intersection B. So the probability of A and B both happening. And finally, we have this exam question from June 2019 to wrap up. 3 bags A, B, and C each contain 1 red marble and some green marbles. Bag A contains 1 red marble and 9 green marbles only. Bag B contains 1 red marble and 3 green marbles only. And bag C contains 1 red marble and 2 green marbles only. Sasha selects at random 1 marble from bag A. If he selects a red marble, he stops selecting. If the marble is green, he continues by selecting at random one marble from bag B. If he selects a red marble, he stops selecting, and if the marble is green, he continues by selecting at random one marble from bag C. Part A asks us to draw a tree diagram to represent this information. So, starting with bag A. So the probability of picking a red marble is 1 over 10, and a green one is 9 over 10. And if he selects a red marble, he stops selecting, so this is the end of this branch. If the marble is green, he continues by selecting at random one marble from bag B. So looking at bag B now, we have one red marble and four green marbles. So the probability he selects a red marble is going to be 1 over 5, and a green marble 4 over 5. And again, if he selects a red marble, he stops selecting, so the branch ends here. And finally, looking at bag C, we have one red marble and two green marbles, so the probability of picking a red marble here is 1 over 3, and a green marble is 2 over 3. And this is for bag C. Now for part B, we're asked to find the probability that Sasha selects 3 green marbles. So we're following down this green path, so 9/10 here, times 4/5 times 2/3, and that gives us 72 over 150, or 0.48. Now for part C, we're asked to find the probability that Sasha selects at least one marble of each colour. So if we write down all the possible paths through the tree, then our first path is just selecting a red marble from bag A, which doesn't give us one of each. Then we have a green marble from bag A, then a red marble from bag B, which does give us one of each. Then we have a green marble from bag A green one from bag B, and a red one from bag C, which also gives us one of each, at least one of each. And then finally, we have a green marble from A, B, and C, which doesn't give us one of each. So we're looking for the probability of a green, then red, and a green, and a green, and then a red. So this probability here, following these branches here, we have 9/10 times a fifth. And then for the other route, GGR, GGR, so we have 9/10 times 4/5 times a third. And adding these two together, we get 21 over 50, which is equal to 0.42. And finally, for part D, given that Sasha selects a red marble, find the probability that he selects it from bag B. So we have the red is selected from B, given that Sasha selects a red. So this is equal to, using our conditional probability formula, this is equal to the probability that a red is selected and it's from B over the probability that a red is selected. So the probability that a red is selected and the red is from B is equal to the probability of selecting G from bag A and then selecting and red from bag B. So that is equal to 9/10 times 1/5. And the probability that a red is selected is equal to 1 minus the probability that no reds are selected. So green, 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 and that is equal to 1 minus 9/10 times 4/5 times 2/3. So this is equal to 9 over 50 over 13 over 25, and this is equal to 9 over 26, and that is our final answer. And that is the end of the chapter summary for Edexcel's A2 Statistics Chapter 2. I hope you enjoyed this video and found it useful, and I hope to see you for Chapter 3.